All right. Good morning, good evening, good afternoon, whatever time it is that you're watching this. Hopefully that your day is going well thus far. And this whole unit seems to be going, at a good pace for you. We're going to get started with lesson 6 today. So if you have your packet, please turn to page 21. That is where we're going to begin. So just to recap, we in our last lesson introduced a new type of function, which is called a logarithm. So we looked at the components of a logarithm. We've looked at how we can compute logarithms, bouncing back and forth between those and exponential functions. So we looked at how we can alternate between the two. And we also looked at how we can compute them algebraically and how we can use our calculator to also solve for logarithms. So we kind of have both options in our back pocket if we need to. So today we're still going to be looking at logarithms, but we're going to look at some properties of logarithms. So we're going to look at what are some things that you can actually do to them and what are some things that you can't do. All right. So with that, to kind of give us an idea of where to start, we're going to look at the do now on page 21 to begin. So your do now from today, you're going to use your notes from last period or the last lesson, and we want to try to solve this logarithm. This is what we know. We just know that if the log base 2 of this fraction is equal to 2, we are trying to figure out what can we use for our value for x to make this whole entire thing true. All right, so I want you to try this out on your own for a couple minutes, see if you can get an answer or see if you can get on the right track, and then we'll go over it together. So pause your video at this time, try it out, and then we'll come back and look at it together. All right, welcome back. So hopefully you had a chance to actually go over this problem together or try it on your own. So we're going to look at it together. So if I'm trying to solve for this logarithm and trying to identify what this value for x is, the first thing I would do is first off, let's just go ahead and write this logarithm out in exponential form. This will be our best friend in terms of trying to solve for these types of functions. So remember, if we're trying to write this in exponential form, what we do is that we start with our base. This is our base, which is 2. So we're going to start 2. Our exponent is whatever number is on the right side of our equation by itself. So our exponent here is 2. And this equals whatever is inside of our logarithm. So this fraction, we're going to write here. So this is how we can write our logarithm in exponential form. Now, take it one step further, we already know that 2 squared, well, that is equal to 4. So really, we have 4 is equal to 64 over x. So now at this point, we're just trying to figure out, okay, well, 64 divided by what number is going to give me 4? So there's a couple of ways we can go about approaching this. Some of us might already have an idea of what this number might be, but in case if you don't know that, what we can do is we can do a little bit of some cross multiplication. So the butterfly effect that some of us might know is that we will multiply these two things and then we will multiply these two things. So if we were to do that, well, then we have 4x, because 4 times x is equal to 64 times 1, which is 64. And now if I want to get x by itself, what I need to do is just that I need to divide both sides by 4. So if I do that, I get x is equal to, and then 64 divided by 4 is 16. So that will be our final answer for the do now. So yes, we did do a little bit of algebra for this problem, but the key thing here to kind of get this problem started is that we need to make sure we take this logarithm and write it out in exponential form. That's going to be a crucial first step for us, especially when we go later on in this unit in solving logarithms and logarithmic equations. And this is going to be our best friend. So, since we're continuing looking at logarithms, there are a couple of properties that we need to get ourselves comfortable and familiar with. There's a total of 4 properties in terms of logarithms that we're going to talk about, and they are listed at the bottom of the page. All right, so the first property when it comes to logarithms is what's called the product property. So basically what this is that if you are multiplying two things inside of a logarithm, what you can do is that you can split it up into two parts. So you can split this logarithm up into two, and what we're going to do in the middle is that we're going to add those together. So as an example, if we have the log of, let's say, 9 times x, what you can do is that you can break this up as the log of 9 plus the log of x. So I split it up into two parts. So you can do that for multiplication and you can do it for division as well. The only difference is that if you're multiplying, you can add the numbers or you can add the logarithms together. But if you're dividing, you're going to have a minus sign in the middle. All right. So like for here, in this example, if you have the log of 4 over 5, what you can do is that you can break it up into two parts. You have the log of 4, you have the log of 5, and then you're just subtracting those because you're dividing inside of the function. All right. So those are the first two properties. The next one is, well, what happens if you have an exponent inside of your logarithm? So what you can do is that if you have an exponent inside of your logarithm, just move it out to the front. So think of that as like your coefficient. So if you have an exponent, just move it in front of the logarithm. So in this case here, if I have the log of 8 to the power of x, take that x, that is your exponent, move it to the front. So in this case, you have x times the log of 8. That's how you just get rid of that. And then the last property is the equality property, where if you have two logarithms that have the same base and they are equal to each other, then what that means is that whatever's inside of their logarithms also have to be equal to each other. Okay, so in this example, if I have the log of 3x minus 4, and we're saying this equals the log of 5x plus 2, well, note here that both of these logarithms have the same base, which in this case is 8. So because these logarithms have the same base, that means that whatever's inside of them has to be equal to each other. So in this case, 3x minus 4 has to equal 5x plus 2. All right, so these are the four big components or properties with logarithms, and we're going to be doing some practice with this momentarily in terms of how we can expand logarithms. And at the same time, we're going to look at how we can actually condense them as well. So we're going to move on to the next page. So I'm going to move at page 22, and we have a couple of practice problems that we're going to look at together. All right, so let's take a look at this first one. So we have the natural log of 4x, and what we're trying to figure out is which one of these expressions is this equal to? All right, so we're going to use some of those properties that we looked at from the previous page to try to see if we can expand this out. So first off, I noticed that inside of my logarithm, I'm multiplying two things. I have 4 times x. So remember, with that product property, what we can do is that we can split it up into two parts. We have the natural log of 4, and we have the natural log of x. And since we're multiplying these two things, what that means is that in the middle, we are adding them. So we can simplify or we can break this up as the natural log of 4 plus the natural log of x. And if we look at our answer choices, this matches answer choice C. So that is going to be our answer for number 1. So let's look at number 2. Same idea. This time we have the logarithm of this guy here. Right? So we're taking the log of x squared divided by k, and we are trying to basically break this up and expand it as much as possible. So, a couple steps here. One thing I noticed is that we are dividing two things. We are dividing x squared and we're dividing k. So what that tells us is that, okay, with dividing, we're going to split it up into two parts. We have the log of x squared, that's 1. And then we have the log of k. And since we're dividing these two things, that means that in the middle, we have a subtraction sign. Now, looking at my options here, this doesn't match anything that we have just yet. So that means that we might have some more editing that we have to do here. The next thing I might notice is, well, this logarithm has an exponent because we have an exponent here of 2. And so if we remember that power property, it says, hey, take your exponent, move it to the front. So that 2 now goes to the front. So we can rewrite this as 2 times the log of x minus the log of k. So this is as simplified as we can get with this logarithm. And now if I look at what I have here and compare it to my answer choices that I have, the only one that matches what we have here is answer choice D. All right, so that's all I can do with this problem, so I'm going to keep going. All right, so now we are looking at question 3, where same idea, we had the log base 3 of 27x cubed, and we are trying to figure out, well, what in the world does this logarithm equal to compared to our answer choices? All right, so first things first, we are multiplying two things. We are multiplying 27 times x to the third power. So you know what that means? That means that, well, we're going to split up our logarithm into two parts. We have the log base 3 of 27. We have the log base 3 of x cubed. And since we're multiplying these two things, that means that in the middle, we're going to be adding them. All right. So now, this part here, let's talk about this log base 3 of 27. This is actually just a number. So if you want to actually figure out, well, what is this equal to? Well, we actually talked about in our last lesson how we can solve for a logarithm like this. If I want to use my calculator to figure out what this is, well, log base 3 of 27, how we can find that, all we have to do with our calculator is that we have to do the log of 27 divided by the log of 3. So we just need to type that into our calculator and see what we get. And if we did that, what our answer should be is 3. All right, so really, all this first part is equal to is just the number 3. So that's the first part, but then we have the second part where we have the log base 3 of x cubed. Remember, hey, this here, we have an exponent of 3. So with the power rule, what that means is that, hey, take this exponent, move it to the front. All right. So really what this second part is equal to is that all we just have is 3 log base 3 of x. So really what we have as our final answer, this first component is 3. So I'm just going to write this to the side. We have 3. And then for the second part, we just figured out that this is 3 log base 3 of x. Move this to the side. So this is actually our final answer. And if we look at this answer here and compare it to our answer choices, it actually turns out that our answer for this is going to be letter B. All right, so so this problem is unique because not only are we using the properties that we just talked about on the previous page for this, but it also is taking us one step further a little bit into our last lesson where we had to also figure out, well, this is just going to give us a number, but we had to figure out what that number is. So we had to take our calculator to kind of give us some insight on what that is going to be. All right, and then for this last problem on page 22, it's kind of like a word problem. We are trying to solve for this here, and we have a couple of pieces of information here, but we'll get to that in a second. First things first is that we want to see if we can try to expand this, all right, as much as possible. So let's try that out. So we might notice that inside of our natural log, we are multiplying three different things. We have x squared times y cubed times z. So just like what we have done before, when you're multiplying a bunch of things inside of your logarithm, we're going to be splitting them all up. All right. So in this aspect, we have the natural log of x squared. We have the natural log of y cubed. So we're literally splitting up each part. So we should have three components. All right. And since we're multiplying all of these things, we're going to be adding them all together. Now, this first natural log that has an exponent that tells us move it to the front. The second one also has an exponent of 3. So this thing we're going to move to the front here. So really what we have for this is that we have 2 times the natural log of x plus 3 times the natural log of y plus the natural log of z. Now, we are not done with this problem yet. Now, we're going to use these pieces of information that we started with to help simplify this even further. So the first part tells us that the natural log of x is equal to 6. So that means that this part here, this is just the number 6. It tells us the natural log of y is equal to 4. So we just have this here. This part is equal to 4. And then the natural log of z, it tells us, is equal to 10. So what do we really have? What we really have is that we have 2 times 6 plus 3 times 4 plus 10. And if we were to simplify this, well, 2 times 6, that is 12. 3 times 4 is also 12. And then we have 10. So if we were to add these three numbers together, 12, 12, and 10, we would get 34. So we just simplified all of this using our properties of logarithms, and we just got the number 34, which, looking at our answer choices here, is just the letter A. So this is how we can use the properties of logarithms to kind of expand them out to get whatever it is that we're trying to solve for. All right. So if we look at page 23, at the top of page 23, question 5, you have two additional problems listed here at the top. All right. The goal is that we're going to apply our properties of logarithms to see if we can simplify each of these logarithms provided. Now, you're going to get some time to try to work on this on your own, and then I'll share the answer with you. But before you start trying this out on your own, the one thing I just want to point out is that for this problem here, where you have the square root of this thing as a little hint to help you out with this, we can actually rewrite this. So the square root is the same thing as having an exponent of 1/2. All right, so this will probably be a little bit easier for you to compute in terms of trying to figure this thing out. All right, so now I'm going to give you all a couple of minutes, maybe 5 or 10 minutes, try it on your own first, in which I want you to see if you can simplify these logarithms provided. And then once you unpause the video after I give these directions, then you're going to see what the answers to both of these are. All right, so go ahead, take a couple minutes, see if you can try to simplify either one or both of these logarithms, and then you'll see the answer here momentarily. So at this time, go ahead and pause your video. All right, so at this point, we are going to look at both of these problems together, and I'm going to show you the steps that I did to get to the final answers. All right, now, if you did not get to the final components or you might have been stuck along the way, good, because I kind of expected that to happen. All right, so I just wanted to show you a couple of things that you might have encountered along the way. So first off, The first thing is that I noticed that we are dividing two things. We have x to the fourth divided by 4y squared. So since we're dividing two things, remember we're going to split up our logarithm into two parts. So we have uh, the log of x to the fourth, and we have the log of 4y squared. And since we're dividing these two things, we're going to have a minus sign in the middle. Now, if I took a look at my first logarithm here, notice that we have an exponent of 4. So if we have an exponent, take that, move it to the front. So if I did that, we have 4 log with the base of 9 of x. That's it. We can't do anything more with that first part, so we're going to move on to the second one. Now, note here for the second logarithm, we're multiplying two things because we have 4 times y squared. So since we're multiplying two things here, that means that, yes, we're going to have to split up this logarithm as well. So we split it up into two parts. We have the log of 4, and we have the log of y squared. And since we're multiplying these two things, that means that we have a plus sign in the middle. Now, this part here, I can't do anything more with it unless if you actually want to figure out what this value is. If you want to, be my guest, but I didn't in this case, so I just left it. But in this case, I have the log of y squared. Note that we have an exponent, so because we have that, we have to move it to the front. So that means that this part here, we can rewrite as 2 times the log with the base of 9 of y. Now, at this point, I can't do anything else. So that means that this entire expression is my final answer. So that's part A. Now, looking at part B, I already gave you the first step, which was instead of having the square root, we can rewrite this as x to the seventh y cubed to the 1/2 power, because that's what the square root is. So I have this exponent here on the outside. So what I can do is that I can just move this 1/2 to the front, which is what I did. So I have 1/2 log of x to the seventh y cubed. Now we are multiplying two things. So again, split it up into two parts. And since we're multiplying, that means that we have a plus sign in the middle. Now for this, I have an exponent of 7, so I have to move that to the front. And for this logarithm, I have an exponent of 3, so I have to move that to the front here as well. Now, a couple things here. Since we already have a coefficient in the front, and we had to split up this logarithm into two parts, note here that I have a 1/2 in front of both of these logarithms. Please make sure that if you are splitting up your logarithm and there's a coefficient already in the front, that coefficient goes to both parts. It just doesn't go to one, it goes to both. All right, so please make sure you be careful about that. And then also, if I have an exponent and I say move it to the front, but I already have something already in the front, well, really all you have to do is just multiply those two things together. So in this case here, since I'm moving 7 to the front, but I already have a 1/2 there, what I'm just doing is that I'm multiplying 1/2 times 7. So if I do that, I get 7 over 2. In this case, since I'm moving a 3 out to the front, well, in this case, I have to do 3 times 1/2, which is 3/2. So my final answer for part B here is 7/2 times the log of x plus 3/2 times the log of y. I can't do anything else with that, so I am done. So hopefully that kind of makes some sense in terms of not only properties of logarithms, but just kind of identifying, well, what exactly can I do and what I can't do when I start expanding these things out. All right. So then the last thing that you all have for this lesson on page 23 is that you have some independent practice. Now, in these four problems on your independent practice, which I'm kind of moving up and down here, is that you're kind of working backwards for these problems, meaning you have these expressions that are already kind of expanded. And the goal here is that you're trying to take each of these expressions and write them as just one single logarithm. So kind of like we're doing what we did up here on this page and on the previous page in reverse. All right. So now we're going to do one problem together. We're going to do number one just so you can have an idea of what you might have to do for these remaining problems. So let's go ahead and look at it. So we have 2 times the log of u plus 7 times the log of v. So we want to condense this, or we want to try to scrunch it together as um, one logarithm. So first thing I'm going to do, and I'm going to look for, is if we have any coefficients. This first thing, or this first logarithm has a coefficient of 2. Now, if you have a coefficient, what that means is that, okay, we're going to move this back inside, and this is going to be an exponent. Same thing with this 7. We're going to move this back inside of our logarithm, and it's going to be an exponent here. So we can rewrite this as the log base 4 of u to the second power plus log base 4 of v to the 7th power. So note here how normally when we had exponents, we always said move it to the front. But since we already have exponents already in the front here and we're trying to work backwards, that means that these now become exponents, these coefficients. Now we have 2 logarithms that have the same base, and we are adding these 2 things together. So if we're working backwards, we already said that if we're multiplying, or if we have 2 logarithms that have the same base and are added, and we want to combine them together, that means that we have to multiply the 2 things inside of our logarithm. So what we have here is the log base 4 of u squared times v to the 7th power. So for this problem, what we did is that we started with something that has already been expanded. And now what we did is that we did our properties of logarithms in reverse, to where at this point, we made this whole entire expression into one single logarithm. I can't do anything more with this. So now I am done. Now, I'm going to do just one more. I thought I was only going to do one, but I decided, hey, why not? I'm going to do the second one for you as well. All right, so same idea. We're trying to see if we can combine this thing into one logarithm. So first off, there is no coefficient for this part, so I don't have to deal with that. But I do have a coefficient for the second part, which in this case is 4. So that means that same idea, I have to move it back inside of my logarithm. And in this case here, your exponent for the second guy is going to be 4. So we're going to rewrite this as the natural log of x minus the natural log of y to the 4th power. Now, in this case here, I have 2 logarithms, which in this case, both natural logs, and I am subtracting them. So if I want to combine these 2 things together and we have subtraction, we're not going to multiply like we did up here. No, instead, we're going to do division. So really what we have here is that we have the natural log of x divided by y to the 4th power. And now, same thing what we did for number one, we took this expression and we used our properties of logarithms in reverse, to where we have this now written as one natural log. So now, because I did that, I am done. So that is how we deal with these first 2 problems. Now, you have questions 3 and 4 left in your independent practice. So you need to make sure that before you go into your exit ticket, you have these 2 guys knocked out. So that way, the next time we meet for lesson 7, we can get that checked off for you so that we can get credit for this entire lesson. Now, just like I just mentioned, is that once you finish the final 2 independent practice problems, you do have an exit ticket for lesson 6. You might have heard from my previous lesson, from lesson 5, that we did not have an exit ticket for that, but we do have one for this lesson here. And it's actually going to combine what we learned from lesson 5 and what we learned from this lesson here together. So your exit ticket is a little bit longer. I think it has 9 questions on it. And the reason why is just because, well, quite frankly, it's two exit tickets in one. All right. So I just want to show you this right quick so that way you have exactly or you know exactly what it is that you're going to or how you're going to access it. So give me 1 second. Okay, so with your exit ticket here, all right, there's a couple of ways that you can go about looking at it or accessing it. So the first way that you can do this is if you go to the Illuminate the Student Portal app on Clever, you'll be able to access the exit ticket from there. But if you have questions or if you cannot get to the student portal app on Clever for whatever reason, you can also use this code here to access the exit ticket for this. If you can't see, it is U3W 8D9A. So that is going to be the access code that you can use also to look at this exit ticket. Now, if let me see, the exit ticket here, I have it where it's going to open on the 12th at 9 a.m. So hopefully by the time you're looking at this video, the exit ticket is already going to be open and available for you. And I'm giving everybody up until Sunday, November 16th at 11:59 p.m. to complete the exit ticket for this lesson. So you got quite a few days to actually get it done. So there should be no reason as to why you can't do it, whether that's, oh, you can't access it in class or whatever, that's fine. You have over the weekend as well to get it done. So if you feel like that's going to be an issue, or if you feel like you're going to have trouble with completing it before Sunday, please let me know so that way I can give you an extension if need be. But otherwise, you have all this time, whether it's the rest of the class period that you have to work on those independent practice problems in the exit ticket, or if you might, I believe it's a B day on Friday, don't quote me, might be an A day, I don't know. But if you have class on Friday, you also have that opportunity to work on that. And you have the weekend as well. Hopefully you don't need it, but just get it done as soon as you can. All right, but that is the end of lesson 6. We only have 2 more lessons now before we are done with unit 3. All right, and as we get closer to unit 3 or the end of unit 3, we're getting close to when I return back to school as well. So mark this on your calendars. I am returning back to school December 5th, which I believe is a Friday. So chances are I should be coming in December 5th. But if I don't, what might happen is that I might just come in instead on December 8th, because that's going to be the start of a fresh week. And that's going to be, I believe that's actually going to be testing week as well for us. So that'll be perfect for us to kind of do some review together before you take your exam and before that leads us into midterms as well, because that is coming up as well. All right, so exciting time. It's going to be we're almost there. We're almost at the end of this hump. But I appreciate everybody who still, looks at these videos, who actually still like engages with it, ask me questions online or text me questions because I appreciate it and it shows me that you're still trying to learn even when I'm out. So we're almost there. I'm almost back into the school building, but in the meantime, if you do have questions about anything, feel free to reach out. Otherwise, enjoy the rest of your day. And I will see you all next week for lesson 7.